Hi there, I'm Andrew Harnett with Haas Automation. Most every machinist is quite familiar with running flood coolant. But in recent years, more attention is being paid to another means of keeping your tools sharp while you're cutting. It's usually referred to as minimum quantity lubrication, MQL for short. Use a stream of air to deliver a fine oil mist to the cutting zone and deliver just enough oil to make sure the cut is adequately lubricated. Today, we're going to look at how Haas is putting the MQL process to work on our CNC mills. And with us here, we have Matt Silva. He's one of our applications engineers, and he's going to run us through some of the finer points of how we use this option on our machines. So, Matt, why is anyone going to go to the trouble of implementing another tool lubrication system when their flood coolant is working just fine?
When a shop needs to machine parts where water-based coolant just cannot be used, this sets them on a path to finding other ways of keeping their cutting tools sharp. Using MQL, you consume at a minimum 5 times less the amount of concentrate than you would when using flood coolant. And depending on your material and cutting tools, there's potential to improve tool life as well.
Now, MQL piggybacks on top of the auto air gun option, right?
Right, it just gets added on.
So I do need to have AAG installed in order to add MQL to it.
Yeah, so here we have our auto air gun body. Attached to that is our MQL nozzle with our oil supply line running to the reservoir on the side of the machine.
So that means I can use it as an auto air gun, or I can use it as an MQL system, and it also doesn't interfere with my regular flood coolant system.
Yeah, you don't have to completely convert to using MQL. Just use MQL wherever that approach makes sense and switch back to using flood coolant wherever that works.
So, can you show us what you have going on this machine here?
So we're cutting some steel on this VM3 here using a combination of high feed milling and MQL lubrication. I'm profiling the OD and the ID of this part using high performance carbide. The carbide, along with the aluminum titanium nitride, work well in this MQL application where we have higher cutting zone temperatures. And the high feed milling toolpath strategy that we're using allows us to send the heat away from the cutting zone and into the chip.
One of the tips to getting the most out of MQL is selecting a cutting process and a tool that's going to move heat away from the cut.
Yes, moving heat away allows the tool to stabilize to an acceptable cutting temperature. And with optimization, this can even lead to improved tool life. One of the potential problems when using flood coolant is thermal shock to the tool. The tool heats up rapidly in the cutting zone and then cools down rapidly, and then heats up and then cools down rapidly. With MQL, you don't have that problem. The oil mist keeps frictional heat to a minimum, and the tool temperature stays constant.
So let's jog Z down and take a closer look at the MQL system. Another thing that's cool about integrating this with the auto air gun is when I need to use it, I just command it to come in, and then when I don't, I just retract it.
That's correct. Some other systems on the market have stationary mountings. This can be a problem when trying to get the nozzle out of the way, say during a tool change or close quarters work. With our system, you don't have that problem.
Can you show us some of the things we need to know about setting up the MQL system?
You bet. Let's start by adjusting the atomizer nozzle. First, I'll close the doors and activate an M83. Now I'm going to adjust the atomizer nozzle about 1 to 3 inches away from the tool.
So you've got your distance set, and it looks like you've got the nozzle pointed at the tip of the tool.
Yeah, so typically you'd want to point the nozzle towards the tip of the tool, but other times you may need to move it up towards the middle a little bit if the tool is partially obstructed.
How do I know I've got enough oil reaching the tool?
Well, most people tend to have the atomizer set to what ends up being too rich of a setting. If you can see oil mist coming out of the nozzle, it's probably set way too high.
We're using the oil that comes with the unit, of course. Can you show us what a good baseline atomizer setting is?
Yeah, sure. So we're going to take and rotate the nozzle so that the adjustment screw is facing us. Now I'm going to rotate the screw clockwise until it seats gently in place. Remember that this is our coarse adjustment. We'll take a look at our fine adjustment in a minute. With the screw closed, no oil is emitted and it functions just like the auto air gun. From here, adjust the atomizer screw to about 1/4 of a turnout. This is a good initial setting. Remember, if you can see oil mist coming out of the nozzle, you probably have it set way too high.
So you've got your atomizer set. Now, I'm going to take this tool out of here, and then maybe you can show us what happens as you increase your atomizer setting.
Yeah, we're going to tape this piece of cardboard to the top of these parts to show you the difference between 4 atomizer settings. We're activating MQL for 10 seconds each time, and the nozzle is 3 inches away for all 4 positions. So the only thing we're changing is the atomizer screw opening.
It's pretty obvious that as we open up that atomizer screw, we get more and more oil deposited.
That's right. Base setting is quite light. The quarter setting is probably the most commonly used. The 3/8 setting is getting a little heavy, and the half is probably too much oil for most applications.
So what about tapping? Does it function kind of like cutting does with MQL?
Well, MQL works great for tapping. In the past, I've seen a lot of shops physically open their door and squirt cutting fluid on the tap. But with MQL, that completely solves that problem. Now it's fully automatic, and we're delivering a consistent amount of cutting fluid to the tool every time.
Sounds good. Can we move around to the side of the machine and take a look at the MQL reservoir over there?
Sure. So over here, we have our reservoir. And just above that, we have our air pressure regulator. This regulates the amount of air pressure that's running through the MQL system. And what's really great about this is I'm able to fine-tune the amount of oil that's being delivered to my tool.
So basically at the nozzle, your atomizer screw, that's kind of your coarse adjustment, and then this is your fine adjustment,
Yeah,
right?
This is my fine adjustment here. And what's really nice, we've put this in a location that's easy to view, easy to access. Every day I can walk up and check the amount of cutting fluid that's in the reservoir. If I need to make an adjustment, it's all right here. And if I need to add more cutting fluid, I simply just come over here with this wrench, put it on here, open it up, add my oil, and close it when I'm done.
Simple and easy.
Yeah.
So it also looks like we've got a list of oils that we can reference here.
Right. And we're actually using one of the recommended oils that's approved and on this list.
That's great. And some people even go so far as to use like regular mineral and canola oils, right?
Right. So all those that you just mentioned, including what's on the list, those are all safe and non-toxic.
Sounds good. Let's head back to the front of the machine.
All right.
So how much of that oil are we actually using?
We're using about half an ounce of oil per hour of cutting. This is pretty typical of an MQL application, and some run even leaner than this.
Wow, that's not much oil. So for comparison, how much regular coolant are we using on this machine?
So we're using about 20 gallons of coolant per week, and that's mixed at a 6% concentration. We're doing about 20 hours of cutting. It takes over a gallon of concentrate to make 20 gallons of coolant.
Now you were just saying that when you're using MQL, you're using less than half an ounce of oil per hour of cutting. So that means those same 20 hours of cutting is only going to cost us about 10 ounces of oil.
That's right.
So basically, at the very least, we're using 10 times less MQL oil than we are coolant concentrate.
Let me put some dollars to it. It costs about $5 and change to cut for 20 hours with MQL versus $45 to cut with flood coolant. MQL can definitely save you a lot of money.
Cut your parts without water-based coolant, potentially increase tool life, and save money on concentrate. And I also don't have to give up my flood coolant in order to get all the benefits of MQL.
Yeah, we don't want to take away the customer's choice on which approach fits their parts best.
That makes perfect sense. Give the customer the choice. Thanks for your time, Matt.
No problem, Andrew.